you ask some questions, or maybe and if the answer is real obvious, we can talk about like, well, why is that the answer? That way we've got something there.
Okay, right.
All right, so tell me what you see, or maybe you already know the answer, or you're not sure.
This one, are they the same?
Yeah, it kind of looks that way, but here's what I want you to see first. If I don't draw this other one, how can we find the arc over here? This is an inscribed angle, by the way.
Inscribed.
So you do something to this number. I can just tell you, but
divide it by, multiply by 2.
multiply 2. Yes. So you got a calculator. I'm going to multiply that for us, please.
Yes. 172.
172. Good. Now that's 172. This blue, I'm going to do this in blue here, is 360 minus 172. Because you got to go all the way around to get that.
Right.
What does that become?
From 188.
Okay. And then notice I've drawn kind of this other angle here, which is an inscribed angle, but its arc is the 188 because they both touch. They're in the same spot.
Right.
Okay. So how do you go back to get X? You kind of already did this.
Divide 188 by 2.
Yes. So X would be maybe 94 degrees.
Yes. Okay.
All right. I don't know. Any thoughts on that, or, kind of probably pretty easy to say, I think it's 86. The removal of lines is kind of a normal thing to do in in particular your class. So if it seems too easy, I mean, based on your book, I would say you probably need to do something else. Not sure how your teacher sets up tests, but the book, it's never that easy in the book here.
Yeah.
But hey, we're practicing for the test, so all right. All right, letter B, we're finding the measure of angle X. X is exterior to the circle. This arc is 86. You can try working this out, or you can let me know if you need a hint here.
Okay. Is it? Oh, wait, sorry. Is it 97?
The final answer?
Yes.
Okay, so the thing one is to find this arc right here, which is 360 minus 86, which for the purposes we'll just get 274. So X is the major arc minus the minor arc divided by 2. So the major arc is this M, this is little m. So we got 274 minus 86. divided by 2. Does that look kind of like what you did?
Yes.
And I believe, sorry, I don't have my usual stuff up because of this computer restarting over and over again. When these internet outages occur, all right, we got 294. You said 94 degrees.
Yes.
Okay, good. All right. All right, so C is actually the easiest of the bunch here. But it looks odd. I'll just say that it probably looks odd more than anything. What kind of an angle is X?
Is it a tangent chord?
It is, yes. But in terms of that's the lengths. In terms of the angle, though, it's a inscribed angle.
Okay.
Does that make sense? Maybe.
Yes.
Okay. So inscribed angles is half of the arc, which is just 43.
Okay. Got it.
All right. Any questions up for me on to number 2?
No.
Okay. Do you get a formula sheet for this test?
Yes.
All right, so like this one I just gave you here, this might be good to put on there. The inscribed angle formula, where here's X, this is 2X, that might be good to put on there. Something like that.
Okay.
All right, let's look at this one here. If AB equals 98 degrees, it's that one, and CD equals 34 degrees. Okay, find X and find Y. All right. So the difference here between X and Y is that X is inside the circle, but it's not a central angle. So there's 3 types of angles. There's the central angle. There's the inscribed. And then there's none of those first 2. There's the center, and there's the other angle. It's cut by chords.
Right.
So in that third case, which is what we've got here, and maybe we'll call it chords. In that third case, it's big M plus M over 2. So kind of similar, right? Big M, little m, got a 2, but this time you're finding the average of the arcs. That's little m, that's big M.
Right.
I
Okay.
think we might have even done that in a lesson, so I'm looking familiar. You want to go ahead and calculate that for us, please?
Yes. Um, 66.
Yeah, 66 degrees. Y is exterior. So that's the major minus the minor over 2. The major being the larger one, not really major, but think of it as the bigger one. I mean, this is my notation, so you may have seen something similar in the book. The reason it's not the whole arc is because it's secant.
Okay.
So in this case, 98 minus 34 divided by 2.
32.
Yeah. Good. So again, a couple more formulas to remember. It's important not just to have the formulas though, but know like which one they're for. This is exterior. And it works for when you have two tangents, a tangent and a secant, or a secant and a secant, referring to those lines that cut through the circle.
Right, okay.
Anything follow up on that? Any thoughts before we move on to 3?
No,
3A?
thank you.
Okay. Mom said you're starting swimming. Is that something you're doing a lot of, or is that just a new thing?
Oh, yeah, my summer team starts tonight.
Oh, cool. Summer. When does that go through the like May? I mean, April, like May, June. I mean, how much
It ends in July. This is preseason.
preseason? Okay. Yeah, interesting. I have a lot of swimmers that I've helped over the years in math. That's wouldn't have known. Might have to start advertising at the pool.
Yeah, right.
All right, so find BD. BD is a chord. Why is BD a chord? What is it that we don't see here, or we can't assume?
Because they end inside the circle.
They're inside the circle, but they do not go through the center, which probably be a little bit off center here, but they don't go through the center. So in a chord situation, like we've got here, they usually go like A, B, C, D, like that. It's A times B equals C times D. So can you use that formula to find D for us, player? For us here, please.
Yes. $12.
Yes, D is 12. That doesn't seem to scale, but I don't know. That just doesn't seem right.
Yeah.
That's okay. Now BD in this case is taking C plus D. So 4 plus 12, which is 16.
Okay.
All right, so let's look at PT there. Let part B, 3B, find PT. Any idea how to do something like this where you've got what's called a tangent to a secant?
Is it the major minus the minor?
So we're finding lengths of sides now, no more angles. And actually, let me go back. This is another formula you might want to get down in your notebook there, note card. This one, I do it this way. I call it part and whole. And this one just happened, like the part is the whole equals the whole.
Okay.
They use letters in books, but like here's what it is. It's the part times the whole of the first one. So in the case like this one down here equals the part times the whole of the second one. So you want to identify the whole length here, which is 16. So it's 4 times 16. That's the part times the whole equals, on the other one here, we'll just call it X. The part is the whole, so you multiply X times X.
Okay.
So notice we got 64 equals X squared. X equals plus or minus 8. So what is the answer here? What would you do in this situation when you've got two numbers that it could be?
Well, you can't have a negative length,
That's
so
right. So it's just the positive one. And if you're wondering why why that is, happy to provide some explanation on that, but we also don't need to. Your answer is what you just said is perfect for how to do this.
okay.
All right, so part C.
So for this one, do you do
So let's call this X there for the moment. And then what's the hole on the bottom and then the hole on the top?
the bottom is 15 and the
Okay,
top is 5x 5
five
plus
plus X.
x.
So your part times hole on the bottom is 3 times 15, but on the top there, what is your part time?
5x.
5 is the part times 5 plus X. So part, when I say part, I'm referring to the part outside the circle.
Okay.
And then the whole is I consider that to be the full length. Your book will do things like have something where it's like A, B, C, D, and it'll say A times A plus B equals C times C plus D. For me, I really like the simplicity of part and whole. But if you don't like that, that's okay. Use this down here. That is we are adding them together to find the whole.
Okay. Okay. Is it 4?
So here's how I check. It's kind of the same way as solving it. This is 45. Is 5 times 9 equal to 45? Yeah, it is. So you can always check your answers. They can make them so that they're fractional or decimal. But you've seen your test to know if that's kind of the situation you're getting into. Meaning, like, how does your instructor typically do it? But
Yeah.
so what we've just done applies to the three circles. It applies to the secant, tangent, and then secant and a tangent. But typically, because all tangent lines are congruent, typically you don't get the middle one. You just get these two on the left, the one on the left and the one on the right. A, B, C, D, A, B. Oh, I gave you two of those. Sorry. All right, I'm way off. Whoops. All right, so there it is. So that's, A, B, C if you want. That's B plus C. Is that clear? I mean, I can give you more detail on this. I don't know if you want it.
No, that makes sense.
Okay, great. So I've grabbed another problem here for us to look at, number 4, or A. All right, find the radius of each circle. All right, so when you see that this whole length is 24, what does that tell you about this length right here?
It's 12.
It's 12. And while what's drawn here is a radius, so is that one right there. And this is a right triangle. How do you find the third side of right triangle?
It's the 5 times.
Pythagorean theorem, right?
Right.
So maybe another thing to put down. Not sure, but yeah, go ahead and calculate that for us, please.
Um, 13.
13, good. All right. So let's say I wanted you to find, I'll call this A right here, the distance from the edge to that horizontal line. How would you find that based on what you just calculated?
Do you do 13 minus 5?
Yes. So not to scale, but yeah, A would be 13 minus 5 or 8. All right. Let's do another one here. All right, so another right triangle here. It's not stated that way, but if the hypotenuse goes through if the hypotenuse is a diameter, which it is if it goes to the center, then this makes a right triangle. That might be something to put on a note card or not.
Okay. For this one, what was it asking for?
First thing I want you to is find the hypotenuse. Sorry if I'm being clear. I want you to first find the hypotenuse, and then which is the diameter, and then you can use that to find the radius. That's what it's asking for, by the way. But
8.5 for the radius. Oh,
yes, yeah, because this is 17, so you cut it in half. 8.5. Very good. You seem like you did that and you're like, no, that's not right.
yeah.
All right, so yeah, again, maybe something to put down on a note card, not sure. But here we go. All right, so this one here, we need to draw one little thing there. Do you remember the angle that's made by the tangent and a radius in a circle?
I don't remember them. Oh, is it 90 again?
Yes. Yeah, so like you don't want to just like assume kind of like that first problem. It's like, oh, they're just the same, but like sometimes it's like, well, that's the only thing you can do. So this time you're finding the third side of a right triangle.
Right.
So go ahead and calculate B for us, please.
34 and 34.7.
So remember, it's A squared plus B squared equals C squared. Your A is 24, B is unknown, but the right side is 25 squared.
Okay, okay. So just 7.
Yes, B is 7. Good. Excellent. Okay. Slowly moving through these, but you're doing great. I feel like we did 5 another time. We absolutely, we can always do it again, but yeah, just look this here. So we got the circles showed are concentric at O. Concentric means they have the same center. PZ and PY are tangent. Okay. That means that PW and PX are congruent. Not that that maybe matters here, but that is the case here. If Y to Z is 110, that's over here. Find the measure of WX. So in terms of the larger circle, and again, this is one of those where it's like, it's really nice if you don't draw everything. Okay.
Mhm.
Can you tell me the measure of angle P from that, from the larger one? You know, what kind of,
Uh,
angle is that from something we did earlier?
inscribed.
Inscribed.
So
Okay.
55.
Yeah. All right. Now, if we draw just the smaller circle, and I know this is the hard part. It's like, how do you even know what to draw? And I guess it's just experience here, but that's 55 degrees. Okay. And we want to find the measure of WX. So we really want this one. I don't know what to call it here. I'll call it the minor, maybe. How do we find the major? Like, let's just say we knew M. How would we find the major?
You do 360 minus M.
Yeah. All right. So that's where we're going. This is like big M. So 360 minus M minus little m. This is the major minus the minor, all over 2. All over 2 equals the 55. So notice there's just one variable that you can solve for m.
Right. Um, can you show me how to do this one?
Sure. So you're going to go ahead and multiply both sides by 2. So that's 110 equals 360 minus 2m.
Okay.
You're gonna add 2m to both sides. And you're gonna subtract 110.
Oh, all right, okay.
So m equals 125.
Got it, thank you.
All right, so just, you probably see this pattern here of me, adding or removing lines, just showing certain lines.
I'm sorry, can you repeat that?
Well, sometimes you remove something or like see how this first picture only has the outermost one here,
Yes.
and then this one has the innermost one here.
Yes.
All right. Okay, so let's move on here. Sorry, another problem here. Set A. All right, let's look at this. All right, given triangle ABC is isosceles with base AB, angle DAC equals 70, arc BC equals 160, find AB and AD. So really, if you, I know you don't have this in front of you to write on, but like there's so much here, you just got to try, writing a few things down. DAC, that's 70. That's this one right here. Can you tell me which arc that corresponds to? Which one's inscribed, which one it's inscribed to?
C to D.
Yeah, so this one over here would be 140. Sometimes it's good to like do that. BC is 160. So that one's here. And we want to find AB, arc AB right here, and AD like that. Okay. Oh, and it's important. Triangle ABC is isosceles. That's really important. ABC is isosceles. Okay. So that means that this side is congruent to this side. Although, yeah, because it tells you that it's base AB. That's how you know, which means that this angle is congruent to this angle. So this is kind of like the last one where there's so much going on here that it may not be easy to see, but you can now find the base angle of the triangle. Do you can you tell me or try to see if you can figure that out without me jumping in?
Yes. So angle BAC is 80, right?
Say that one more time.
Angle BAC is 80.
Yes, yes. So that also tells you what this other base angle is. It's also 80. And it also tells you what the other angle up here at the top is, because all three angles have to add up to 180. So what would that put it at?
20.
20. Good. And then B to A is based on that 20. What does that become?
Then it's 40.
Yep. All right, so notice the only missing arc we don't have is A to D. but we have all the other ones going around the circle. How can you find the missing arc?
You add them all together and you subtract that number from 360.
Yes. So what does that become?
20.
20 degrees. Make sure that degree symbol's there. So AB, arc AB is 40 degrees and AD is 20 degrees.
Okay.
All right. I think we got everything on that one knocked out. 7. Look at 7 next. Do you normally get a study guide or review or anything heading into your?
We do like in-class reviews. But this time he didn't assign the review as a grade.
Okay. So radius OY is 6 centimeters here. Central angle XOY is 45 degrees. We want to first find the length of XY. So length, you got to be careful. Length is not the same as the arc measure. Okay. If it wanted the measure of XY, that's when you would want the angle. Like the measure of XY is 45 degrees right here, but it wants the actual like walking distance of it. Okay, so to do this, there's a couple of ways. Your book probably gives you a formula like S equals R theta.
Right?
Is that okay?
Yes.
But the problem here is theta is in radians. So I don't really like this formula. I usually I give students or go with this when I say, okay, the circumference of a circle is 2 pi r, okay, or pi times d. If you want to find just the length of a sector, okay, the sector, it's the same formula, 2 pi r, but you take the angle and you divide it by 360. Because this angle divided by 360 is the part of the circle that you care about, like the walking distance around.
Right. Okay.
All right, so that would be 45 over 360 times 2 times pi times 6. If you need this exact, you would do everything but the pi part. Do you have a calculator handy?
Yes.
Okay, so do everything but the pi, put everything else but the pi in the calculator, and then
1.5 pi.
yeah, 1/8, 3/2 pi. And then this does have units because it's a walking distance. It is centimeters. Sometimes they want the exact. I'm sorry, this is the exact. Sometimes they want you to approximate. You can put that in your calculator. So the next thing here is the perimeter. So that's going all the way around. We now don't know this one's 3/2 pi. What's the distance from O to X?
6 centimeters.
Yeah. So we just add them up. The perimeter, part B, your perimeter is 6 plus 6 plus 3/2 pi, 12 plus 3/2 pi centimeters. Yeah. I don't know. I guess there's a formula here to remember, circumference. There's this one that you normally get, but I prefer the one down here. I think it's a little bit more intuitive.
Yeah, okay.
All right. Are you doing any proofs?
I'm not sure. I think maybe one or two.
Okay.
I hope not.
Yeah, me too. We haven't done much on proofs. We probably I mean I don't really want to. I mean I never want to do proofs, but we we should at least talk about what some of the proofs are referring to. So OM bisects AOB, angle AOB. What they're trying to show you here is if you have two radii and a chord connecting them, this altitude here meets at a 90-degree angle, and you can end up proving that these triangles are congruent to each other, which means that corresponding parts of congruent triangles are congruent. You end up getting all of this is congruent, sides as well. You can do it a few different ways, angle, side, a few others, but that's the big one here. The big one, we used it earlier, is that you have two radii, chord connecting them. This thing right here always meets at a 90-degree. And then you get up, these are congruent, these are congruent, these are congruent, that's congruent. Now this one's asking you to prove that, but rather not. Probably better using our time on some other questions, but that's certainly something to consider. The other thing I'll point out here that maybe isn't obvious at first glance is that this triangle right here is an isosceles triangle. That's the main reason, and because the radii are congruent, same sides, same angles.
Okay, right.
All right, here's I like problems like this because this next one here, because you do have to attempt to draw this. So a parallelogram with sides 4 and 7.5 is inscribed in a circle. Find the radius of the circle. It doesn't necessarily matter. And I know normally you go right to the circle. That may not be the right thing here, but you can imagine sides of 4 and 4. Now it's a parallelogram, so these have to be congruent. So somehow, we got to get a circle out of this. I don't really know how that works, but it probably, let's assume it works. This probably goes through the center. Okay.
Okay.
So 4, 7.5, and then that means this is probably 90 degrees here. So you can find the hypotenuse of that for us,
Okay.
please.
Okay.
Does appear to be a nice number at first glance.
Um, 8.5.
Yes. This ends up being an 8, 15, 17 triangle. So C is 8.5. That's the whole length. So the radius would be 8.5 divided by 2, or 4.25.
Okay. Got it.
All right. So here's we had one of these earlier, not sure why all of a sudden this is showing up again, but this is a tangent and a secant. TP is 8, PQ is 6, RQ is unknown. Can you set this up for us? What would be the whole here?
6 plus X.
Yes. So give me the setup here. What goes on the left side of the equal sign? What goes on the right? for this situation?
6 times 6 plus x
Good.
equals 8.
That's the part and it's the whole. So it's
Equals-
8 times 8.
Okay.
So if you left it as an 8, I'll just show you that over here, you would have gotten 36 plus x, and you would have found that x equals minus 28, and that's bad
Right.
because it doesn't work out. So part times the whole, like sometimes students remember like tangent squared equals, this times this. I like part and whole. So 64 equals 6 times 6 plus x. Sorry, there's that would have been a 6x. Sorry, and you would have gotten that. Could you attempt solving this for us, please?
Yes. Uh, 4.7.
So this is 36 plus 6x, 64 equals, you're going to move the 36 over, that's 28 equals 6x. So we got 28 divided by 6 equals x, or 14 over 3. You mentioned a decimal, probably better to leave this as a fraction.
Right. Okay.
All right, so that's going to take us to the end of our lesson for today. Go ahead and stop the